what is a problem statement? From where we have this, the question of differentiability will rise. So it is basically it rise with the question of tangent. We know how to calculate the tangent of a linear equation, right? But what if we have
Linear equations, tangent.
yeah, y is equals to mx plus b. We know very well about that. There
Tangent
y,
is basically probably the gradient, right?
yeah, tangent, it's gradient equivalently.
Okay.
So for example, this is our xy plane, and we have a function. Let's the function is like this way. Just look like sinusoidal way. Let me make it.
Oh,
Okay,
wow.
so this is a function. Okay, and my target is to check its tangent at this point. What is its tangent at this point? I let me name this point. It is x, some particular x. Okay. Now,
I know
before
this
that,
part,
before that,
but
before
yet
that,
the normal.
can you please stop
Okay,
writing?
okay, okay.
Yeah, it will be the same curve, but obviously, let me talk. So this would be the tangent line. But now, what is the method? For example, if I take one point of this equation, one point, if I take any 2 points from the equation, okay, from the graph, and I just join them with the help of a line. So that line is called secant line. What you call that line? A line that is passing through any 2 points
Secant line.
is called the secant line. Okay. Now I can calculate the tangent of this secant line because it is a straight line, right? I can calculate its tangent by getting its equation in the form of y is equals to mx plus b. So from that, I can calculate its tangent, even though I can use the formula y is equals to, sorry, m equals to um, y2 minus y1 over x2 minus x1, where I will find the rate of change in the y-axis corresponding to the x-axis, right? So I can get the rate of change, and that would be the tangent, right? So, but if I take these
Yeah,
points,
yeah,
if I take
yeah.
the formula for the slope now, or gradient. So
Yeah.
if I take these points more closer to this point, then I will get a this type of a line. Okay, and if I start following this thing, and I just take a point very close to this point, the yellow point, and I am taking another point, red point, which is very close, very close. Can you see the pink point that I highlighted? Sorry, the red one.
Yeah.
So I took a point very close to the yellow point, and now these are again two different points of the line, and if I join them, they are very close to each other. Okay, so that would be the secant line, right? Now, corresponding to
Yeah.
their x-axis, for example, this is the x point and the yellow point, and the red point is at any step sides. Um, it is the red point is x plus h. Okay, the red point is x plus h, where h is very small number, positive number, or it can be a negative number even. I can take the point to the left side or to the right side of x. Is it clear? And their corresponding
Yeah.
functional values. What are the y values? Usually they are the functional values. So their corresponding functional values are corresponding to f, we have the functional value f of x, and corresponding to x plus h, we have the functional value f of x plus h. Okay, so this is my x1,
Yeah.
this is my x2, this is my y1, this is my y2. Let's substitute them in this formula. So it is y2, which is f of x plus h minus um, f of x, okay, over um, x2 plus h. Sorry, I'm writing x. So x plus h minus x, so that will become f of x plus h minus f of x over h, right? Now, the problem is with h. What is a tangent? Tangent to any curve is a line that is passing through only one point. That is passing through only one point. So how can I join these 2 points together? How much close I can take these points, x plus h and x. I can take them, they can be closer to each other if I approach this point h close to 0. If this point h is approaching to 0, the step size is approaching to 0, that means the points x and x plus h, they are getting closer, closer and closer, right? Is it clear?
Yeah.
So how, when I am saying that the point h is going closer, closer to 0, that basically means if I just apply the limit x to h tends to 0 here. So this is the definition of derivative. Is it clear?
Okay.
So this is a function basically. This is not the function, these are the functional values. And if I can get its limit, then I will say the function is continuous at x. Is it clear? Now,
Yeah.
there are some conditions. If this term is properly defined, if a function is differentiable, if um, limit h tends to 0, f of x plus h minus f of a over h is properly defined. Okay. Now, what does it mean now? The term is properly defined. There are two things. Number one,
The limit
um,
exists.
this is also, but the first one is all the terms. All the terms in the above expression are well defined. Okay, means they are not giving me infinity. Okay, this is x, this is not e, this is x. Okay, they are well defined, they are not giving us any infinity. Clear? And then
Yes.
the limit exists. The limit h tends to 0, um, f of x plus h minus f of x over h exist. Clear?
Yeah. Mostly.
Okay. Now, what does it mean when I say this word? Uh, the function f of x and f of x plus h is well defined. That means basically all the terms are well defined. It means um, f is continuous. F is
It's not like the previous
it,
functions with stop and
uh,
jump.
yeah, with the jump. So it would be continuous. Why it needs to be continuous now? there is a condition, there is again a problem that why we need that it is continuous. So if the function is, just imagine if the function is not continuous. Let's see, let's take a problem and take a function which is not continuous. Um, let's say this is a function. I defined it in some way. Even I haven't any idea. It is f of x. Okay, let it is f of x is defined by 1 if x is less than 1. Okay, this is 1, and it is 2 otherwise if x is greater or equals to 1. Okay, so this is a function now, and I have to calculate its I have to find its tangent, right, at the point 1, but I can't take that tangent, right, because if the function is discontinuous, that means f of x is not defined. Either f of x is not defined, either its limit at this point doesn't exist, right? So we can't take the derivative or
Yeah.
the gradient of discontinuity, or in other words, in very easy words, we cannot draw a tangent at a point that doesn't exist even. Okay, so we cannot draw the point at we can't draw the tangent at a point that doesn't exist. Means if I have to check its continuity, either I have to check it here or either I have to check it here. So there is a problem. So that's the reason it's very it's very weak explanation, but yeah, at this level it is enough, I think so. So that's why we need the function must be continuous. Okay, and then the second condition is the left limit and the right limit exist. Okay, now why this when I say the limit exists, obviously the limit will exist if its left limit and its right limits both are equal, right? Now let's take a problem. um, let's take a function, and we have to check its differentiability at a point. So I'm taking a function. My function is f of x is defined by, it is x squared, and whenever x is lesser than 2, okay, and it is x plus 2 whenever x is greater than or equals to 2. Clear? Now if I have to find its derivative, what I first have to check, I have to calculate its derivative. We have to investigate its derivative.
Investigate.
Yeah, we will check that either it is
Use
exist.
the formula. Okay. Okay.
No, this is not the formula. This is the function. We will investigate that. Investigate the derivative of differentiability at x equals to 2. So we have to check, is it differentiable or not? Okay, I haven't any idea what it would be. So first of all, we have to check either the function is continuous or not, right? This is the first condition. Means if the function is continuous, that means it is well defined. The terms x, f of x plus h and f of x, they are well defined. So first we have to check is it continuous or not. So let's check its continuity. So first of all, we will test f of 2, right? And for f of 2, this function will work because x equals to 2 for this one. So it would be 2 plus 2, that is equals to 4. Now I have to check its limit. I'm this is limit x tends to 2 from the right side. So the function would be, if x is greater than 2, then it would be x plus 2. So it is again 2 plus 2, which is 4 again. Now let's check its left side limit. So in this case it would be x square, because x is lesser than 2. When x is lesser than 2, f is defined by x square. So it would be 2 raised to the power of 2, which is again 4. So now we can easily see that f of 2 and the limit value, limit x tends to 2, f of x, they both are equal and the answer is 4, right? So this is very obvious that the function is continuous. Clear? So the function is continuous, it is satisfying the first condition, right? Let me just draw its curve. I will like to make it.
X square.
Are you checking it? Okay. So let's have.
The curve?
Let me. I'm making the curve here. You just have to observe the things now. So initially I have at 2 I have the function it would break. No, you are making it wrong. Neha, look here, beta. So at 2 x is 2. Okay. So at 2 initially when x is lesser than 2 the function is x square. So I will get a curve of a function x square up till 2. Okay, and I will get a open for this one, right? Because x is lesser than 2, not equals to 2. Clear? Then for the other part,
Okay.
it is x plus 2 when x is greater or equals to 2. So the slope is 1, and I think I will get a, for the red line, it is defined, and it would be 4 approximately. This point is 2, 4. And I will get a curve like this. A straight line now, right? Okay, so now you can see graphically, mathematically, it's been clear that the function is continuous at 2, right? So there is no doubt related to that thing, right? So now now we have to check that. Still, I'm not sure that it is differentiable or not. So let's take the problem further. Let's take it further. So let's try to calculate this function. Now we have to test this function. Does its limit exist or not? Okay. So there are two possibilities. There are two possibilities for the step size h. If h is negative, now think, if h is negative, this term x plus h, it will be lesser than x, right? Because we are subtracting something from x.
Yeah.
So the term will be on the left side of x, right? Is it clear? So that means in that case, we have to work with x squared. So if x is h, I'm just rewriting the definition of the derivative. So limit h tends to 0, f of x plus h minus f of x over h. So now if h is negative, that means x plus h is lesser than x. So Or in other words, now x is 2 basically, so we can say that 2 plus h is lesser than 2, right? If h is negative. Is it clear?
Yeah.
Okay. So then which function will work? Obviously in this one it is x greater than or equals to 2, right? And in this one x is lesser than 2. So when we are talking about h, 2 plus h is lesser than 2, so we will consider this function. Then our f of x will be defined by this way. So we will get limit h tends to 0 f of 2 plus h minus f of 2, because we are testing our derivative at 2, and it will become
I
equals
have
to,
a question, sir.
yes.
Why are you using the part when the equals to is not there over here?
Sorry.
What does this mean?
This term, this thing,
Yeah,
just consider, just initially I told you that h can be positive, h can be
it's the
negative.
negative side of the equation.
Yeah. So I'm taking initially the negative side, then I will take the positive side, and if they both will become equal, that means the derivative exists at that point. Okay.
Okay. I understood. Yeah.
So it will become limit h approaches to 0. So f of 2 plus h, it would be defined by this way, right? Because f of x is defined by x square now. And f of 2 is obviously, it is 4, we already calculated it here. So it is 4 minus over h. Then let's see, let's open the square. So limit h tends to 0. It is 4 plus 2h, and then
It's
plus,
square.
plus h
Oh
square
yeah.
minus 4 over h. So this 4 can be cancelled out with this 4. Yeah, exactly. Thank you. So it would be limit h tends to 0. I can take h common from the numerator, and I will get 4 plus h, right, over
Divided by
8.
1. Okay, or this.
So h will be cancelled out, right? So now I got
Oh yeah, okay.
limit h tends to 0, 4 plus h, and it is 4 plus 0, which is 4. So
Okay.
when we test the limit from the left side, the answer we got is 4, right? Now we have to check it from the right side. So again, I will take the same term, but now if h is positive, that means 2 plus h is greater than h, right? So I will take
Yes.
the x values on the right side of 2. So again, my function was limit h tends to 0, 2 plus f of 2 plus h minus f of 2 over h. Okay, now the function is defined by which way? It is here, x plus 2. Okay, so it will become limit h tends to 0, f of 2 plus h will become x plus 2. Is it clear how I wrote that? By the definition of the function. Minus f of 2 is 4, obviously we already calculated that. over h. Any confusion?
No.
Okay, and then it will become limit h tends to 0. It will become 4 plus h minus 4 over h. 4 will be cancelled out with 4, and I will get limit h tends to 0, h over h. So it is limit h tends to 0, 1, which is equals to 1. So now you can see that when I calculated the function limit, that expressions from the left side I got 4. When I calculated it from the other side I got 1. So they both are not equal. That means that expression that I wrote here for calculating the limit or for calculating the differentiation, that limit doesn't exist, right? So this
Yeah.
function is not differentiable at 2. Now, why I did this problem? Just to tell you that if function is continuous, it is not enough that that function would be differentiable. Okay, it is not guaranteed. This function that we are taking is continuous, but it is not differentiable. Initially, I gave a problem in which the function wasn't continuous, so we didn't went for the differentiability, and now we are at a function which is continuous, but which is not differentiable. Now, if you are given with a graph, why I made that graph? There was a reason. If you are given with a curve or with a graph, and with the help of the graph, you have to check that either the function is differentiable at a point or not. This function, now this is very important point. If you just look at this point, the point 2, 4. At 2, 4, the function is making a corner. The function is making a corner. Okay, it is
Okay.
um, it is the corner point. Okay, and functions are not differentiable at their corner points, because at the corner points the left limit and the right limit of the whole expression, this expression, they both are not equal. Okay, now let me ask you a very quick question. I'm making, this is a function. Let's define f of x by absolute of x. And if I curve this function, if I make its graph, it would be like this. This is the curve, right? And if if I ask you, is it is differentiable? It is continuous at 0. Is it differentiable at 0?
No.
So no. Why? Because it is making a corner. Clear? So from graph, it will
Yes.
become very easy if it is making a corner, a sharp corner. So at that point, the function is not going to be differentiable.
It's
Uh,
differentiable at this point, but
it is,
not at this point.
yes, obviously. Even the same function, the function that we were discussing already in the previous example, that function was also not differentiable at 2, but it was differentiable over the whole real numbers. And this function is also differentiable to all real numbers except 0. Okay, so let's take another
Why not
problem.
zero, sir?
Because at 0, when you will calculate again the same expression, the left limit and the right limit, they both will become different. You can calculate this. Okay, this function is not differentiable at 0. You can check it as I did for the previous example. You can check its left limit, the right limit, and then you will obviously find that the function is not differentiable at this point. Let's take another problem, and we have to investigate its continuity. Okay, investigate. We are not calculating initially, we are just investigating that is it differentiable or not.
Okay. Can I use a graph and just try to see if it's differentiable in a question that says graph is usable?
I think it will depends on the marks. Okay, if it appears
Okay.
for then you have to go for theory. If it is very short question, then I think graph is the best method, and if you are good in graphs, then you can make the graph, and from the graph you can check that. Okay, um,
Okay.
again, differentiability of function. Okay, let's define the function. It is g of x. It is defined by x square and I think 4x minus 4 will be working if x is lesser than 2, and otherwise x is greater or equals to 2. Okay, I think from the graph we can check its continuity, or if you wanted to check it in theory you can also check that, but I will just give you two where's the graphical method. So let's see. Initially at 2 we have to break the function. Okay, so this is a curve of x square. Just let me pass through. Please pass through the origin. Okay, so this is a function for x square, and it is opened for x square because x is lesser than 2, and then there is a function of 4x minus 4. So at 2 you will get again 4, so it is continuous, and then if you take 3, the slope is 4, y intercept is negative 4, so you will get a curve like this. If I'm not wrong, you will get a curve like this. Okay, you can use any graphing method, but I think you will get a curve like this, a very straight curve. Okay, so now you can see it is not making any corner here, right? From the graph it is very clear the function is it is continuous, and from the graph we can also see that at 2 the function is not making any corner. That means the function is differentiable. Now we can quickly test it theoretically. So I think is there any need to check the continuity?
No,
Okay, thank you. So if
because there is
it
no
is from the
corner.
graph, it is clear. Otherwise, we can check that. I think you also know how to check it. Okay, now let's quickly move towards the problem. Hmm. So again, what is the definition of the derivative? It is limit x tends to 0, f of x plus h minus f of x over h. This is the expression. Okay. Again, by the same method, if h is negative, that means 2 plus h is lesser than 2, right? So I have to take the side in which I will get a term lesser than 2, right? X is lesser than 2. So this function will work, and the expression limit h tends to 0 f of x plus h minus f of, let's write it for 2 now. So 2 plus h minus f of 2 over h, that will become equals to 2 plus h square with the limit h tends to 0 minus f of 2 is again 4, you can calculate that, over h, and it is the same expression that we were dealing with, we were dealing initially, and you will get 4. Okay, it is the same expression. We are done with it already. For your satisfaction, I can show you this one.
Okay.
You can see this is the same expression. Limit h tends to 0, 2 plus h square minus 4 over h. And we calculated that it is 4, right?
Yes.
Now, if h is positive, this is a new case. If h is positive, at that point 2 plus h will be greater than 2 and the other function will work. So limit h tends to 0, um, f of 2 plus h minus f of 2 over h, it will become um, limit h tends to 0. So it is defined by 4x minus 4. So it will be 4 into 2 plus h minus 4, and f of 2 is also minus 4, right? Is it
Yeah.
clear? Over h. So then in the numerator, I will get 4 times 2 is 8, and 8 minus 8 will be 0. So 4h by h. H will be cancelled out, and I will get limit h tends to 0, 4, which is 4. So now you can see that from the graph, initially I told you that it is continuous. Sorry, it is differentiable, and the derivative is 4. But now I calculated that theoretically, that when we will solve this, the derivative will be 4. Is it clear?
Yeah.
Okay. Any question?
No.
Okay. Thank you so much then.